first thing that we're going to review for exams is we're going to look at function notation. And so if we remember, function notation is when we're talking about a relationship that we know is functional, which means that for every x value, there's only one y value, which you can review in your notes. And we use the notation of f of x. So if we're given an equation like this one here, f of x equals negative x squared plus 2x minus 1, we're talking about a quadratic function, and g of x equals 2x minus 5, we have a linear function. If we are asked to find f of 1 minus g of 0, we need to sub in 1 for the x values in the f function. So I'm going to open up a set of brackets like this and show you how I'm subbing in 1. So we have negative of 1 squared plus 2 times 1 minus 1 as our f function, and we are subtracting when we plug in 0 into the g function. So using your calculators, you guys can simplify that. So f of 1, we have negative 1 plus 2 minus 1, so we actually get 0 for the first part, minus, and we have a negative 5, and because we're subtracting a negative 5, the final answer is 5. For the second function, or sorry, the second example, we have f of g of 1, which means first we're going to find g of 1, and we're going to take that answer and plug it into the f function, because g of 1, you can see here, is inside the f function. So g of 1 is 2 times 1 minus 5, which is negative 3. And then the second step is that we now know the answer to g of 1. So we're going to find f of that answer, which was negative 3. And now looking at the f function, we have negative of negative 3 squared plus 2 times negative 3 minus 1. And so we have, be careful with the negative here, we have a negative that's not being squared, times negative 3 squared is positive 9. And then we have minus 6 minus 1. So we have negative 9, negative 6, and negative 1, which makes negative 16. So to review this, you can always go back in the lesson to look at function notation. And we're going to move on to the next example. So the other thing that we learned in this unit was we learned about domain and range. And domain, just to review, means that we are looking at the x values that exist in the function. And range means we are looking at the y values that exist in the function. When we're looking at domain, we'll use this example of a circle. We're looking from left, the x values, to right. And when we're talking about a circle, we're looking at all the x values that exist here. So the domain is between negative 2 and 6. And we're going to use square brackets. Square brackets means that it exists on that value, or at that value. Okay, and for range, we're looking at the y values, so from bottom to top, always go from negative to the positive. So in this case, negative 4, and then everything in between and up to and including to positive 4. When we're looking at a parabola, we should have arrows on the end because this does continue forever. We have the domain of negative infinity to infinity, and this time we use round brackets because we don't know the exact value that it starts and ends at, because infinity is a number that we don't have the exact value for. And when we're looking at range, again, we go from bottom up to the top. So in this case, it starts on negative 3, and it continues infinite numbers up to infinity. So we have a round bracket there. Okay, moving on. For these examples, we are looking at the vertex form of a parabola, which is what we looked at in Unit 1 in a lot of detail. And we looked at all of, let me rewrite that a different way. We looked at all of the parameters that change a basic parabola. So we have the a value, which has two functions. It either stretches, or some of you wrote shrinks or compresses, or it shows a reflection in the graph, flips it upside down if it's negative. The h value shifts it right or left. And if you go back in your notes and review, it always did the opposite of what it said. So if it said a plus 2, then we move left. If it's at a -2, we move right. And the k is up or down. So if we take a look at these functions here, these are all different parabolas. And we'll just look at the first one, or let's do one row at a time. So the k value is your shift up or down. So here our k value is 4, 6, 0, because there's nothing over there, and -3. So this one would go down 3. Horizontal shift is, again, the opposite of what it says. So here it says -2. So we're going 2, and if you want to write to the right to help you out, because there's no value being added or subtracted to the x there before being squared, there's no horizontal shift. Here it's also 3 to the right. Oops, let me fix that. 3 to the right. And here we have 4, and because it says +4, we are going 4 to the left. In terms of stretches or shrinks, we're looking at the a value, which would be what is being multiplied in front of the x. So here it's a value of 1, a value of 2 being multiplied by the x squared, a half, so that would be a shrink. And here the stretch is actually a 1. The negative means that there's a reflection. So that's not how it stretches. That changes the direction. Direction in here is opening up because it's positive, so it's a smiley face, right? Up like this. And this one has a negative, therefore this is the reflection, so that it's upside down like a frown. So using this information, we know that the vertex then, let me just, why this isn't going there. Okay, using this information, we know that the vertex therefore moved right 2, up 4, 0, up 6, 3, 0, and -4 down to -3. And we can now look at the line of symmetry. The line of symmetry is always for the x value of the vertex, and that is where the mirror image of the graph is through. So it's always an x equals equation, x equals 2 because it's a vertical line, x equals 0. When we do the graphing, I will give you a visual to explain, and -4. Domain for all parabolas is always the same. You might want to write a note that it's always -infinity to infinity, because parabolas continue forever. And range is always based on the y value of the vertex, and whether it is opening up or down. Okay, so range has to do with the vertex and the direction. So the range here, because it's opening up, starts at 4, and it opens up to infinity, starts at 6 to infinity, starts at 0 to infinity, and this one starts from -infinity, and it ends at -3. If you take a look at this little sketch, you can see that it's the negative direction. I'm not sure if we were supposed to graph those. Yeah, so on here, oops, we can do the graph of all 4 of them. So the first one, we're at 2, 4, and opening up. So I'll just do different colors. So we go over 2, up 4, and from there we're opening up, and we go, our step pattern is for every 1 squared, we go up 1. For every 2 squared, change that a little, you go up 4. 1, 2, 3, 4 from the vertex. And you can see the y-intercept there is at 8. So we can connect those. Oops, hopefully you can do it a little nicer than that. So that would be the first one. And I'll just put a little black squiggle to show. This one was at 0, 6, opening up with a stretch. Let's be careful here. We have a stretch of 2. So what that's going to do is change our steps. So we go 0, 6 is the starting position. And instead of going over 1, up 1, we're stretching by 2. So it goes up twice as high. And the next step would have been at 2, 8, because it stretches twice as high, which is off the grid. So we'll just connect. Oops, there should be these 3 dots. Should be there. If it helps you, You might want to look at your over and up steps, which I taught in the first unit. If it goes over 1, because we're doing x squared, 1 squared is 1, and over 2 from the vertex squared is 4. So if we're changing the stretch, then you're changing the y values. So let's do another example. So that one was blue. So let's do red. This time we're going over 3, and it's a stretch of a half. So at 3, 0, and now we're stretching by a half. So half of this would be going up halfway. And instead of going over 2 up 4, we're stretching it or shrinking it to half. So it's only up 2. So you can see that it looks shorter and wider. Okay, and the fourth one, left 4 down 3, and no stretch, opening down. So we'll do that in green. Left 4, down 3, opening down. So now you're going down 1, 1, down 2, 4. With a mirror image on the other side. Connect it. Okay, hopefully you're connecting nicer than I am. And there we go. So let's move on to factoring. So you should have an arrow going this way, and it should say factor. I think it got cut off, right? So if you take standard form and you factor it, you're putting it into brackets. And if you have factor form and you expand it, you're going back into standard form. So in order to factor, you always want to look for common factors first, if possible. So in this one, because we have 4, 7, and 2, there are no common factors. So we're going to go right into what multiplies to the first and last, which we call the AC. A is the first term, C the last. So what multiplies to -8, and what adds to the middle, the B term. So what adds to 7. So two numbers that multiply to -8 and add to 7. So that would be 8 and -1. They multiply to a negative and add to +7. We take the middle term and we break it down into those two terms. So plus 8x minus x, and then we have the -2. We have not changed the equation. We've rewritten the middle term into two separate terms that add to 7. So we have decomposed. We can now factor the groups. So we take a look at the first set. We factor out a 4x. We're left with x plus 2. Second set, we factor out a -1. We're left with x plus 2. We should be left with the same bracket so that we can factor that out. And then we're left with 4x minus 1 as our second factor. If we take a look at this next one, we're going to do the same thing. So what multiplies to -27 times 2 is -54. And what adds to -3. So we're looking at 9 and 6. We want the 9 to be negative to make it add to -3. So we rewrite it as 2x squared minus 9x plus 6x minus 27. And it doesn't matter which order you put these two factors in. Either way it will work out. Here we can only factor out an x of the first two terms and left with 2x minus 9. Here we can factor out a 3, and we're again left with 2x minus 9. And we're left with 2x minus 9 as one factor, and x plus 3 as the other. If you were to put the 6 and the 9 in opposite order, you would eventually get the exact same final answer. So we're doing the same thing here. No common factors. So what multiplies to 12 and 5 makes -60, and what adds to -28. So that would be, we have to think about that for a second. So we're looking at 30 and 2. We want 30 to be negative, so it adds to a -28, sorry. So we have 5x squared minus 30x. Oops. I have to make the right pen. 5x, okay. Try that again. 5x squared minus 30x plus 2x minus 12. In the first two, you can factor out a 5x, and you're left with x minus 6. You can factor out a plus 2, and you're left with x minus 6. And your factors are x minus 6 and 5x plus 2. If you wanted to check your answer, you can expand this all out and see what you got. Here we have what multiplies to 36 and adds to negative 13. So we're talking about negative 9 and negative 4. They have to multiply to a positive and add to a negative. 4x squared, I'll put the 4 first, it doesn't matter either way, minus 9x plus 9. Factor out of 4x, you're left with x minus 1. Factor out of negative 9, you're left with x minus 1. 1 factor is x minus 1. 1 is 4x minus 9, which is. Okay, next example. Application. So this could be similar to what you can expect on the exam for application. A javelin is thrown from a raised platform. Its height is given by this function here. So if we wanted to just draw a sketch, we're starting at 25, because if you were to plug in 0 for time, you would be left with an initial height of 25. And a javelin is being thrown. So a javelin is kind of like a stick you would throw up in the air, and it would eventually come down. Find the zeros. Other words for zeros, x-intercepts or the roots, or where it lands on the ground. Different ways to ask that question. In order to do that, you're looking for a height of 0. So we set the equation equal to 0. We're using t instead of x for time. And we're going to solve this by factoring. We are going to common factor first by factoring out a negative 5. We're left with t squared minus 4t minus 5. We had something like this on the test in this unit. And then we are going to factor this quadratic. If we factor, we need two numbers that multiply to negative 5 and add to negative 4. So that would be negative 5 and positive 1. Because there's no number in front of the t squared, you can go right to putting it in the brackets. You can review simple trinomials in your notes. And we're going to get two final answers for t. T can equal positive 5 or t can equal negative 1. Now, because this is a word problem, if you look at the diagram, the negative 1 would have been down here on the left, and t equals 5 would be over here. This is the only realistic answer because you cannot have negative time. Therefore, a better question would say the javelin lands at 5 seconds. Okay. There's special type of factoring. If you notice that there are perfect squares in the first and the last terms, then you can skip steps. These are perfect square trinomial factors and difference of squares. Here we have the middle term is missing, and it's a difference of squares. It'll be because the middle term has canceled to 0. So the middle is missing. And if you know that the middle is missing, you know that you're going to have two brackets that are almost identical. One's going to say plus a number, one's going to say minus that number, so that you can see when you expand it, the middles would cancel out. Okay, so here's an example of difference of squares. An example of perfect squares, if I were to go through my decomposition steps, I'd be looking for numbers that multiply to 9 and add to 6, and I would find that my numbers were 3 and 3. Because I get the same number twice, that is a clue that I actually get the same bracket twice, which I could write as a square, and the bracket is x plus that number, which is a positive 3. Same with this one. Here, if I multiply to 36 and add to negative 12, my numbers are negative 6 and negative 6. Notice the middle term is negative. This factors right away to d minus 6, that number, twice. Here we have common factors. You can common factor out a 49. Actually, you common factor out of 2. And we're left with 49m squared minus 81. We now have a 2 as a factor, and we have a middle term missing situation. where we have 7 times 7 making the 49, and then we can do a plus 9, minus 9 for the 81. If you have trouble with this, we need to review the entire lesson. Okay, at this point you are ready to start the exam review for the summative, which will be handed out Wednesday, and you are ready for the Unit 1 and 2 section. Please also go back and relearn those lessons for the examples you had trouble for, and try doing the chapter review and the test over again. Good luck.